Hello and welcome back. So in this episode we will shifting our gears. In the previous videos we explored the general workflow from uploading or editing the pressure and rate data toward generating the analytical and numerical modeling using different methods, and also explored how to do uncertainty and sensitivity to generate multiple realization. Today, one of the most important videos that we will have here in this playlist, which is relating to the design of the test itself. So, for example, before we can dig in, let's step back. In this channel, we are trying to deliver the real field cases. We're trying to deliver the experience, not just button clicking for the most of the software. So bear with me if this video will be long, not like the previous videos, but I'm trying to transfer the experience itself. So for example, if you have like an exploratory well and you have just like a geological subsurface map, topographic map, and the geologists that make the maps or the interpretation says that you have like a fault away from your well. It's around 500 meter, and depending on this fault he make like three-way or whatever the structure he supposed to you, and make like a volumetric calculation and provide a preliminary volumetrics and original oil in place or gas in place, whatever. So you need to confirm this using the well testing, which is the preliminary tool that you have for limited or short time of production. Maybe you are experiencing this well on offshore or onshore, and you don't have a round facility, so you have a limited time to evaluate this well and take the decision after that to drill another well or not. Or maybe it's kinda of sandless and have a limited reserves, so you don't want your company to invest a lot of money in this area, because after, if you take like a wrong decision, at the end of the day all the company will be heard and you will be kicked off from the company. So one of the most important tools that you can use is to design your test before you can do your analysis or doing your program and pushing to the operation to execute the operation for you from the memory gauging and this and testing over the different rates. So how we can do this, how we can elaborate this, is just very simple using the Sapphire. I will go here to Planck to initialize a new one, a new document, and as you can see from the previous, this is the same. Previously we explored the reference information units. I will keep everything default, and this for analysis, okay, and I will leave the radius like this, base zone already, and maybe I will change the base zone to like 60. Base zone is like the net pay, the whole reservoir, okay. So you may like make partial penetration, you may prefer just the top 20. Maybe you have an aquifer underneath the reservoir, your sand, productive sand for that feeding the oil, so you don't want to make like an early breakthrough or cooning, so you prefer it like the first 20 feet. And this for of course will make like an impact and signature on your analysis by imposing like a signature in the early time. Okay, so also I will go for the porosity. I will change it to like 15%, and the top of the reservoir maybe I will change it to 8,000. Okay, make this like 5.354. Okay, next I will leave as it oil. I will not define any advanced BVT. Okay, I can change it later, no worries about it. Okay, for the beta O I will make it like this. Viscosity, maybe it's like 4.4. Total compressibility, I will leave it like this, and saturation will be like 10%. Okay, next I will leave everything as default. Okay, so now I can close this browser. In the normal procedure, the first step is to load the Q and B, but now it's totally different. I will go to map. Okay, supposedly that you have already a map, already you have from the geologist or whatever the place you get the map from, and by loading the map from here and making the contour over the map, you can trying to moving all the features from the map toward your model. But we will not do this now. We will keep it just simple to show you the general idea. So the first thing you will have here like this contour line, okay, and this is your boundaries, and also you will have here like a tested well. I can change this contour line whatever the shape I want, so I will click on the contour and I will make it like this. Okay, just click on the corners. Okay, and back to click again to the contour to confirm that you are satisfying with this dimension. Okay, the second thing that I want to do is to make a scaling, to transfer the actual scale to my map. Okay, so what I can do is I'm going to local XY, okay, and by changing the option to scale the field, okay, and I will change the unit from feet to meter, and by click from the well and drag to this end, okay, so now it represents like 781 meter. I will make it like 1000 meter. Okay, then click apply. Now we're good. Okay, I want to test what I did already, and if everything is going okay as designed, so I will click on measure and just click here and drag. As you can see here, the distance is already measured like 3300, which is around the 1 kilometer that we already proposed. Okay, also I want to make another feature to my design by introducing like fault. So I will click here. I will not complicate it. I will not make it complicate. So I will disable this. So if you want to complicate or make like a fault, you can create like this. And now you created, okay, you created a fault. And also you can create another fault. So now you make your model more sophisticated. It depends on your situation, by the way, and this is like maybe acting like a channel, and you can test the wave of the well test will reach the fault number 1 or number 2 firstly, how it will behave on the derivative itself. Okay, so for now and for simplicity I will just delete all of these faults. Okay, so the next step will be designing our well. We already have a predefined one, okay, and if you want to add another one, just click on well and introduce another one. Maybe you need to test like the effect of injection on production, maybe some kind of interference test. You have all the options here. So I will disable also the well because I want it very simple, and just double click on the well. Maybe I can change the name here to test one. Okay, and as you can see, the default for the perforation is some kinda to cover all the reservoir, which if you can remember, it's like 60 feet. And here the ZW is representing the distance from the bottom of the reservoir to the center of the perforation. Okay, so some kinda, I don't want to make the perforation to take the whole length. I have different options. I can edit the perforation. Maybe I can snap it. I'm sorry, I can click here, and if I can drag from here, so I already changed the perforation length. So I have here partial penetration. Okay, and this of course will be affect my derivative in the early time for the transient, and will give us like a spherical flow, okay, which is characterized by the slope of my -1. Also, I can edit the perforation by coming to here and just editing this, or adding the perforation, whatever the way that you prefer. So I prefer like make it okay 840. That's it. Okay, so as you can see here, everything is changed for us. Also, the bottom measure depth is already for the sensor data, where your memory gauges will be positioned. Also, you have here a scan factor, so maybe I can introduce like 1, and after that you can make like a sensitivity over this number. Okay, so I'm thinking that we're good here in this modeling. Okay, so the next step, we should go to the additional tools, and you have two options here, is to create like analytical design or numerical design. If you prefer to go with analytical design, so all what we did will not be reflected here. You have here certain amount of predefined template, like for the reservoir model, if you have it like homogeneous, whatever. Also the boundary model, what you want for the boundary, and you can fill here all the reservoir parameters. Okay, and after that you will click on history, and then adding the Q, and the model or the software will try to sensitize your pressure data and give you the response. So I will not go with this option for the analytical, and I will go with numerical design to capture all what I did here in the map. Okay, as you can see here, all what we did already is reflected here. Okay, so I will go to history and click add. So some kinda after the perforation we shut in the well before opening, so we can give it like 5 hours as a duration, and the rate will be 0. The second thing, we have like a flowing period for like 2 days, which is very long by the way, but this is for kind of demonstration. And here we have a large area. Okay, take this in your consideration, and I will make it like 200, just 200 barrels per day, and I did this in purpose, deliberately, to show you something, and this is something in the nuances of the well testing. And after that I have to like change the shutting period. I'm satisfying with 96 hours. Okay, and the rate will be 0. We will come back again to this design. Okay, so if I click the gauges, this is the resolution, this is everything. If you want to make anything, also you can introduce some noise. So once I click generate, so the software now is trying to make like a model for us. So as you can see now, this is a 3D model, a numerical one that created for us, and also this is the proposed or the anticipated pressure response depending on the production that we already delivered for the software. So the next step is just to click on extract. Okay, and as you can see everything is okay, and click OK. So as you can see here, everything is okay for us. We can change this, and this K will be as the same K already in the input data. And as you can see, it's some kind of, we have already the derivative is going downward, which is like indication on the build up about the closed system, but it's not clear. Maybe with some kind of engineers, maybe they can consider this as like a noise or end effect, whatever. So maybe we can come again to the edit QAC. I just need to show you how it is very easy for us. Okay, and I will change this to like 1000. Okay, and once I click again on the additional tools, it need to update the whole thing. So start update from the start, and as you can see, nothing changed. I changed the rate, aiming that this derivative could be changed. And as you can see, the pseudo-steady state or the radius of investigation is not dependable on the rate itself. If you can recall, the parameter for the radius of investigation is like the equation is like the square root of phi mu ct, whatever the parameters and the constants that already introduced in the equation, and it doesn't have any relation to the rate. So the only parameters that will affect our end effect here or the boundary dominated flow is to increase the time. So I will come back again to the edit QAQC, and I will increase this time to 200 hour. Okay, and then come back to I'm sorry, I did one mistake. So I will make it like 96, and this there is nothing happened here before because I didn't make the most important one, which is additional tool again and numerical design, and go to generate again to generate the whole response for me. Okay, and as you can see here, let me fix this. Okay, and as you can see, nothing is changed as we stated before due to the same tools that we already stated before. So you don't have any clear boundary dominated flow that's describing that we have already a closed system. So what we can do, we can come back again. So in the first step, we changed the rate from 200 to 1000, and nothing happened toward identifying the boundaries. So I will come here to the duration for the shutting period, and I will change it to 200 hour. Then back again to the additional tools, start update, and then numerical design, generate again depending on the new modified data. Okay, so as you can see here, it's better than the previous one, and it's very clear that we have some kind of downward for the derivative. So if I want to make a matching for the model, I will go to analysis, change the tools, and the boundary model I will change it to maybe closed rectangle or rectangle, whatever. Okay, maybe for simplicity I will make like this, rectangle center. Okay, and I will go here. Okay, that's it. So from this, if I make like maximizing for the window and choose the parameters, we have here now area and bulk volume. Okay, and also if I click on the investigation radius, you will see that every time I hover over any point, I can see the radius of investigation and what is the end of the propagation of the wave itself, of the pressure wave. Okay, so from here we can also calculate the original oil in place. Just to close this, minimize it again, and from here I can choose this period. I can anticipate that this period is the radial flow, which is representing for the transient period. So by just right click and click on single line, and then just hover over the radial flow, and as you can see, automatically it detected also and draw another line on the similar plot. So now you have the capability to deliver any design, to know what is how your reservoir will behave during your test. You reduce the uncertainty from 100% to just maybe 40%, 30%. So this is very important and crucial to do your design before doing your well testing. So that's all for this video. I'm sorry to make it very long, but it's a very important topic to talk about and one of the most important videos. If you found it useful, please like, share, and subscribe. See you later in the upcoming video.